So in this activity, we're going to produce what we call triplets. So I'd start with the cards all laid colour side up, and then I might grab one card. So for example, let's take this one. That's a 12. So, and I'm going to put it in one of the spaces. It's entirely up to you where you put it. So I've put 12. I'm going to put the 12 as the result of a multiplication. And then I will find numbers that actually make that multiplication. So two numbers that will multiply to make 12. So 3 could work. What else could I use? 10 will not work. A 4 could work. Okay, so I found a 4 and I found a 3. So if I grab that 3, let's see, that was there. Yes. And there we go. And that's a triplet. So 4, 3, and 12 are a multiplication triplet, because two of them multiplied together make the third number. And that's what we mean by a triplet. And then the challenge is to make as many triplets as you can. So let's make a couple more here anyway. And so I've got to kind of choose another number to, you could choose, one way you could do it is you can choose a number to be the result. Okay, let's try 30. And then people have to find pairs of numbers that would work. So you could do that as a kind of Pellmanism trick, especially where people don't know the cards very well. So then they're looking for two numbers that would work. So 10 would work if I could find a 3, but actually I think I've used a 3, and I don't know if there'll be another one, so let's put that back. 4, no, 4 wouldn't work, so I'll put that back. 6 could work if I could find a 5. And there's a 5. So there we go. I can put the 5 there, and I could put the 6 there. There we go. That's another triplet. And so that's one way of doing a multiplication triplet. Another way of doing it would be using a division, a setup which is division, and that's just as, I can still use 3 cards for that. So let's see. I'm going to go with, let's go with 88. Yeah. And 88 is a really big number, so I'm going to put that as the numerator of the division, or the number I'm going to be dividing. And let's go with, well, what could I use for this? I could use, well, I could use 8. 88, 8 and 11 might work. Let's see, 81, no, that won't work. 18, no, that won't work either. 8, excellent. So I've got an 8, I'm going to put that in there. So 88 divided by 8 should be 11. So I'd need to find 11, not 16, no. Not 9, not 2. 11 is the one, so there we go. So I've managed to make 3 triplets, and that means I've got 3 sets of cards, and each set of cards could form a multiplication or a division with both the calculation and the result. And then the question would be, can you, using this one set of cards, can you create more triplets? And what's the maximum? What's the maximum number of triplets? I'm sure you can get more than 3, but eventually you'd get a maximum, even if it's just based on the number of cards that are available. So that's it. Have a go and tell us how many triplets you think you can make.